Hello, I'm Bob Wildfong, and I'm with Seeds of Diversity. Today, I'm going to talk about some tips for pollinator-friendly gardening. Seeds of Diversity is an organization of seed savers. All across Canada, we have members who save seeds from their gardens to share with other members, and the purpose of it is to grow the rarest varieties of garden plants that we can find so that those seeds will be available. And the more people who grow them, the more likely that we will be able to grow them in the future. Pollination is really important for seed saving because insects that pollinate flowers turn the flowers into fruit, and it's inside the fruit where we have the seeds. So if we want to grow seeds as seed savers, we have to know about pollination. And that's why we bring some tips about pollinator-friendly gardening to you so that you can have healthy gardens, healthy pollinators, and more flowers, more fruit, and more food. When we talk about pollinators, most people think about honeybees. Honeybees are kind of like the poster insect for pollination because in agriculture, honeybees are used for pollinating everything from apples to almonds to cherries, all sorts of fruit, all sorts of farm produce. And we're very familiar with honeybees because we get honey from them. That's important. Also, beeswax, that's a great product that comes from honeybees. And pollination is a third really important reason why honeybees are raised. You might see honeybees in your garden. If there are beehives anywhere nearby, honeybees can travel quite a long distance. So they might travel from those hives and visit the flowers in your garden while they're out foraging, looking for pollen and nectar. But also there are wild honeybees. They are originally a wild animal, and they have a tendency to escape from beekeepers and go live on their own sometimes. It's a much more of a challenge now for them to survive in the wild than it once was, but there are wild honeybees, and sometimes they'll come to your garden too. We'll talk a little bit more about how to recognize them. You'll also see bumblebees, and bumblebees are a classic native bee. We have about 25 different kinds of bumblebees in Canada, and if you ever see a fairly large, really fuzzy kind of a bee, chances are that it's a bumblebee. But in fact, there are over 800 different kinds of bees in Canada. We have this very beautiful green glossy agapostemon bee. There are squash bees like the one in the top right. There are leafcutter bees like the one in the bottom right. Also mason bees, sweat bees, cuckoo bees, all kinds. Very few people know all the different kinds, and a lot of them just have scientific names. But the really important thing about native bees is that they've been here for all of time, and so they're very very adapted to the Canadian climate. Whereas honeybees are not from here; they're from Europe and from Africa, and they have sometimes some difficulty handling the Canadian winters. So when we rely on native bees to do our pollination, we're actually relying on a natural resource, which is sustainable. It has sustained Canadian ecosystems and Canadian farms for hundreds of years. And we believe that we will need to rely on native bees to do our pollination if we can't depend completely on honeybees. Many people have some assumptions about bees. And there's a great saying that most of what most people think about bees is false. And what that means is that if you ask most people what they think about bees, they'll usually say three things. People think that bees make honey. And people think that bees are social insects that live in big groups. And people think that bees will sting. And in fact, all those things are sort of true, but actually not very much. Honey. There's only one kind of bee that makes honey. Out of all the 800 different Canadian species of bees, only the honeybee actually makes honey. The others don't. And when we think of bees as social insects that live in great big families, honeybees live in huge families. There can be thousands of bees living in one colony. And bumblebees live in families too. There might be 20 or 25 bumblebees in a colony. But all the bees that you see here, and most of those 800 native species of bees, are solitary animals. They don't have groups. They live just like a lot of other animals do, like rabbits. Rabbits live in a hole by themselves. And bees sometimes sting, but most of them actually don't. The only reason that a bee would ever sting is if it were threatened and if it had something to defend. So honeybees will often sting if a person goes too close to their hive, because they, after all, have thousands of sisters to protect. And if they sense that there's a threat, then stinging is their defense for that. And bumblebees will sting because they also have a family to protect. But neither honeybees nor bumblebees will really be aggressive when they're out foraging. If they're far away from their home, they have nothing nearby to protect. Their best defense is just to get away if they feel danger. And they typically will just do that. They'll just fly away. Now, other bees, like, say, this beautiful green agapostemon bee, lives all by itself. If it feels threatened, it has nothing to defend, nothing to protect other than itself. So its best defense, first defense, is to get away. And only if you were to reach out and grab that flower and grab the bee in your hand would it feel that it needed to sting you. And you know what? That's a lot like how a rabbit would feel. If you were to catch a rabbit, it might bite and scratch to defend itself, but it would only do that if you actually caught it. It wouldn't try to be aggressive. It would try to get away. That's pretty normal, right? That's pretty normal among animals. Think of it that way. Bees really aren't stinging insects in the main. Now, wasps are somehow sort of the more aggressive member of the family. Wasps are actually a primitive kind of bee. Long ago, and I mean millions of years ago, before there were even flowers, the way we know flowers today, there were wasps. And they were carnivorous insects, which they are today. They'll fly around looking for soft little bugs like aphids. And I've actually seen this. They'll pick up aphids from a plant and take them away and eat them. They're carnivorous. They will eat pollen as well, because pollen is a really good, nutritious food. It has lots of nutrients in it. So lots of insects eat pollen as a food, but wasps don't need that. They are the sort of ancestors of bees, in that when flowers that we know evolved, some wasps decided to become vegetarian and just feed on the pollen from those flowers. So the plants needed a pollinator in order to grow these great big flowers and be successful. And the bees needed lots of pollen to survive. And so they evolved together, bees and flowers. The way that we know flowers today are something that could not exist without each other. And they've never existed without each other. So today's wasps are that original carnivorous insect. They have very smooth bodies. They don't pick up pollen very well. Bees are the newer sort of descendant of wasps who have fuzzy bodies, good at picking up pollen, and they are vegetarian. They only eat pollen. We do like wasps, though, even though they're not really great pollinators because they don't pick up very much pollen on their bodies. Wasps do control aphids in the garden, and those little beetle larvae that can damage your plants. They do maintain a balance of insects in your garden by eating some of the, especially the larvae form of insects that can damage your plants. And so having wasps in your garden is not an entirely bad thing, because they do consume some of those insect pests. But wasps tend to be more aggressive than bees. And if you've ever thought that you were stung by a bee, probably in fact you were stung by a wasp, because they tend to be the ones who sting. You'll also see other animals in your garden that look like bees, but they aren't. They're flies. And these two on the left is one called a syrphid fly or a hoverfly. And on the right, this very fuzzy fly is known as a bee fly. They're called that because they have black and yellow stripes, so they kind of look like a bee. And the reason for that is simply that flies have no defense at all. Flies have no stingers, and so they can't defend themselves even if you grab onto them. But this coloration kind of fools the predators. It makes birds think that they're actually bees. It makes them look kind of dangerous. And so it's a protection. They're pretending to be bees and pretending that maybe they would be able to sting even though they can't. Now, you'll never be able to grab onto a fly and find out for sure whether it can sting, because they're very, very, very timid. I have never been able to get anywhere near one of these insects, and have been very lucky to even gotten pictures of them. As soon as you get anywhere close, they sense you and they take off. Whereas bees generally are pretty confident. When they're on a flower, they're busy feeding on the flower. You can get right up close to them, and they won't fly away. Butterflies and moths are minor pollinators. They do visit flowers and they do carry some pollen from flower to flower. So yes, they pollinate, but look at how they're sitting on the flower. The monarch butterfly over on the left is just perched over on the edge of the flower, hanging onto the petals. It isn't getting right in there where the pollen is. So you can imagine that it isn't actually picking up any pollen on its body. And over on the right at the bottom, that's called a beehawk moth. It's a moth, quite large moth, but it's too just hanging onto the petals of the flower, quite some distance away from it. And that tube that's going from its face up and over to the flower, that's its tongue. It's sticking its tongue really far to sip nectar from the flower without actually contacting the flower very much. And so again, you can imagine that it is not actually picking up much pollen on its body and not carrying pollen from flower to flower. So we count butterflies and moths as pollinators because they can pollinate, but they don't very much. It's mostly bees and mostly flies that do our pollination. So that's our quick tour of who our pollinators are. But how can you tell the difference? How could you look at these insects and be able to tell which are which? And there are some things you can look at. Bees and wasps look very similar, but the real giveaway is in the fuzziness on their body. If you see something that might be a bee or a wasp, but it's perfectly smooth and shiny, then it's likely a wasp. If it has some fuzz on it anywhere, has any hairs on it, then it's more likely to be a bee. One of the giveaways is the waist. Look at the wasp, where it's sort of halfway along its body, it gets really thin. That tiny, tiny wasp waist is a big giveaway that that's a wasp. Another clue is that when they're on a flower, not flying, bees will tend to have their wings flat against their back, whereas wasps tend to stick their wings up in the air. So a few things that you can see, you can remember, and you can tell the difference between bees and wasps. Flies are a little harder to tell, but there are a few clues. If you have a good look at its head, then you'll notice that a fly has giant eyes. Its eyes are basically its entire head. And if you can make out where the eyes are and that it has very, very short antennae, then that tells you that it's a fly. Another clue is with the hoverfly, the syrphid fly. That's the one that's pictured here. They can hover perfectly motionless in the air. If you ever see something that looks like a bee, but it's hovering like a helicopter or a hummingbird, perfectly motionless, and then it might zip a little bit over to the side and hover there, that's a fly, because bees can't do that. Telling the difference between butterflies and moths is very tricky. Normally, I can't tell the difference just looking at them, but I can tell the difference by looking at a photo sometimes and zooming in. The antennae is one of the things that you can look for. Moths have feathery antennae. They're like little feathers sticking out of their heads, whereas butterflies have long, straight antennae with balls on the ends of them. If you can't get a good look at the antennae, sometimes you can tell because moths will sit on a flower with their wings flat out horizontally, whereas butterflies tend to fold their wings up vertically. That's another thing you can look for. Ultimately, the difference between butterflies and moths is just for interest. They're very similar as far as what they do in the garden. And you'll also see lots of other kinds of insects in your garden feeding on flowers. Beetles, for example, They can be pollinators. They can pick up pollen, and then as they move from flower to flower, they can move the pollen from one flower to another. So that's pollination. But beetles will probably tend to eat the flowers as much as they pollinate them. So they may do more damage than good. So they're sort of a minor pollinator. Everybody loves honeybees. And the reason that we've loved honeybees for centuries and centuries is mainly because of their honey. Honeybees are the only bee that produce honey. They also produce beeswax. And at one time, it was very difficult to obtain sugar. And honey in some parts of the world was the only source of sweetness, the only thing that you could bake something sweet with. And so honeybees were originally raised for their honey, not for pollination. And then later they were raised for their beeswax, not their pollination. The pollination is actually something that comes along only in the 20th century. There's a wonderful quote here by Jonathan Swift, who you might know as the author of Gulliver's Travels. He wrote that bees fill their hives with honey and wax, thus furnishing the two noblest of things, which are sweetness and light. And that refers to honey, the source of sweetness if you don't have sugar, and light from candles which were made from beeswax. And imagine if you didn't have another source of wax and you didn't have another source of sugar, well, you'd be raising honeybees in order to get those two things. And that's why we have had honeybees in Europe and Africa and Asia for thousands of years. It's not for pollination, it's for their honey and their beeswax. Now, more recently, it became important to have honeybees doing pollination. As recently as the 1920s, we can read about orchardists going through their orchards, looking at their apples and their pears and their cherries, and commenting on the fact that native bees were active and pollinating the flowers. Now, if you had a small orchard, then the native honeybees, or native bumblebees, mason bees and leafcutter bees that were just in the vicinity of the orchard would be able to get to the center of the orchard because the orchard is small. So they'd be able to pollinate the whole thing. But as orchards got bigger and bigger and bigger, it might be difficult for those native insects that lived on the margins to reach all the way to the center of the orchard. And so the pollination might not happen in the center of a large orchard. Also, in the 1920s and 30s, it became standard practice to use pesticides in orchards, and that killed a lot of the native pollinators. And then the trees without pollination didn't bear fruit. So it became a standard practice, along with the pesticides, and of course after the spraying was done, to bring in honeybees into the orchard to do the pollination because the native bees weren't there anymore. You can carry lots of honeybees around because they live in these large colonies. You put them in a box and you move them where you want them to. So you can have honeybees pollinating cherry trees and then apple trees and then raspberries and then squash, and just move them from farm to farm, from place to place. And they can do that pollination work in different places. But it turns out that has been really hard on honeybees, that traveling, that moving, that being in different places. And it has also exposed them to diseases and parasites by introducing them to different places and introducing them to other populations of bees that they would meet along the way. It's just exposed our honeybees to a lot more vectors for parasites and diseases. And that has led to a lot of the trouble of declining honeybee colonies. Honeybees are not from Canada, they're from Europe, and they're not very accustomed to our cold Canadian winters. So if they're already having difficulty with parasites and diseases, and then there's a harsh winter, a lot of the honeybee colonies don't survive. So one of the messages that we're trying to get out there is that we need to rely on our native pollinators the way that we used to. That means making farms either smaller, or if that isn't viable, at least putting pollinator strips. That means having a piece of land maybe in the middle of an orchard so that native pollinators can live in that land and then pollinate the middle part of the orchard. having access to all the trees, having more native pollinators getting to all the trees, and not getting sprayed with pesticides so that they can do that work. And then we'll rely on honeybees a lot less. This is part of the adaptation that's necessary in order to have good functional agricultural pollination. In your garden, you probably don't have honeybees anyway. If you do, then that's really interesting to see. But just because they are suffering so much in the wild also, wild honeybees are also infected with the same kinds of disease and parasites, and so they're suffering, and there are fewer of those wild honeybees than there used to be too. So you're probably in your garden seeing bumblebees more. Bumblebees are really effective with blueberries and tomatoes, and these are blueberries over on the left and a tomato flower on the right. And what's happening in this picture with the tomato flower is that this bumblebee is holding on and shaking the flower to get the pollen out. A tomato flower is all closed up and the pollination is inside that cone. In order to get the pollen out so she can eat it and also collect it and bring it back to feed her young, she's doing something that bumblebees can do that other bees can't do. She can disengage her wings and then use the muscles that would make her wings flap to vibrate her body. So any other bee that tried that, they would just wind up flying away because the wings would still be attached to those muscles. But since bumblebees can disengage their wings, they can use their flight muscles to vibrate their whole body. And just like a salt shaker, shake the pollen out of that tomato flower. She catches it on her belly and she'll put it in this sort of basket. You can see that yellow blob on the side of her body. That's a basket that's there for collecting pollen. She'll brush it into that little basket and carry it home. And leaving that ball of pollen in her nest, she'll lay eggs, and then when the eggs hatch, the little baby bees will have something to eat. Now, blueberries have the same kind of tightly closed up flower. It makes it difficult for honeybees and other kinds of bees to access the flower and get the pollen, but because bumblebees can vibrate them and shake the pollen out to get the pollen, that means they can pollinate blueberries very effectively too. Bumblebees are used agriculturally in greenhouses for this reason. When you get greenhouse tomatoes, very likely it was bumblebees living in the greenhouses who were flying around and pollinating the flowers. And you can buy boxes of bumblebees. There are companies that breed bumblebees and put them in boxes, and you can buy them. You open up a little flap and all the bumblebees fly out into your greenhouse and do the tomato pollination. They're a native insect. We want to protect them, and there are about 25 different kinds, different species of bumblebees. Some of them are very common, and some of them are not. And you can read up on a particular species called the rusty-patched bumblebee. There's a picture on the bottom right. It has that rusty patch on its back. That's what identifies it. But it was very, very close to extinction not long ago, and it may be coming back through the efforts of some pollinator conservancy. The rusty patch bumblebee is one that we might be able to rescue. And as all native bees are having trouble from habitat problems and from pesticides and from a variety of diseases and parasites that might be coming from climate change and the way that honeybees are moving around, native bees are in trouble just as much as honeybees are. We're trying to do our best to figure out which bees are most in need of some assistance and how we can help them. And we're hoping that people in home gardens can help us out with that. And more about that in a minute. Squash bees are a really fun bee if you have them in your garden. And if you have squash or pumpkins or zucchini in your garden, then you almost for sure have squash bees too. Where does squash come from? Squash and pumpkins are from South America originally. Thousands of years ago, indigenous farmers in South America were cultivating squash, and people a little bit further north noticed that and traded with them and started growing squash too. And then people a little further north saw that, traded with them, and started growing squash. And the history of squash farming is an indigenous history of people further and further north growing squash until indigenous farmers in Canada were growing squash. Now, during that whole history, the squash bee, which originated in the same place as squash, and they have coexisted since the very beginning of time. It's a particular species of bee that loves squash pollen, and the squash plant depends on the bee for the pollination. Well, the squash bee started moving further and further north that whole time, and now we have native squash bees in Canada that have adapted to be able to survive our winters. So wherever there is squash, pumpkin, zucchini, anything of that plant family growing, probably there are squash bees as well. And you can notice this, especially in the afternoon, if you look inside a sort of a wilting squash flower, you might find a bee that just looks just like this. And if it's very sleepy, and even if you poke it with your finger, it barely wakes up, then it's a squash bee. Now, there are two kinds of squash bees. There are male and female, and they both eat the same thing, and they both have the same kind of lifestyle in the morning. They get up very early in the morning and eat the pollen from the newly opened squash flowers, but then their days are different after that. The females go into a nest that's just a little hole in the ground underneath the plant. They make balls of pollen, and they stuff their nest with those little balls of pollen, and then they lay eggs on top of the pollen balls. And so that when the eggs hatch, it'll be the following spring that they hatch, the little baby squash bees will have something to eat. Meanwhile, the male squash bees live in the flowers. They tend to sort of roll up inside the flowers in the afternoon and sleep there. Now, here's another thing to know, is only female bees have stingers. We're certain that if we see a wasp or a honeybee, that it might be able to sting us. But we also know in the back of our minds that all female worker bees, or all worker honeybees, are female. And that's true. It turns out that the stinger is part of laying eggs. It's part of the same body part that's used for laying eggs. And so only female bees and wasps have stingers. Probably any wasp that you encounter, any honeybee that you encounter, will be a female, because that's just how their families work. But with these solitary insects, like squash bees, there are about equal numbers of male and female. And so it's quite easy when you look inside a withering squash flower in the afternoon in July, and you find one of these sleepy bees, probably it's a squash bee. And like I said, if you poke it with your finger and it does not move, then it is a squash bee, because any other kind of bee would not tolerate that. They would try to get away. Squash bees are very sleepy in the middle of the afternoon, and only the males are in the flowers, and they don't have stingers. So here's the fun part. If you dare, and you find one of these, you can pick it up, and you put it in your hand and show it to people. And they'll gradually kind of wake up and realize that they're not in the flower anymore, and then they'll try to fly away. But they can't sting. They don't have stingers. So it's kind of a fun thing to be able to handle a real live bee. One of the only times that I would suggest doing it. Leafcutter bees are another a native bee that you might not see the leafcutter bees as much as you see the holes that they make. They're called leafcutter bees because they cut these perfectly nice round holes, in this case in a rose leaf. And this doesn't really damage the rose plant very much. There are other leaves. The amount of leaf surface that they take away is really very minor compared to the whole leaf surface that's available for the plant to use. What she's doing here is she's taking this round piece of leaf and taking it back to her nest, which is a hole in the wall. It looks like this one was drilled. She will have put balls of pollen inside the hole and then laid eggs on those balls of pollen. And now she's sealing the hole up and covering the whole thing with these kind of basically baby blankets made out of leaf. She'll seal it all completely up, and when the eggs hatch, the little larvae that hatch out will have some pollen to eat, and they will live their whole adolescent lives in the hole, eating that pollen, grow up, and when they're adults, they'll emerge and do the whole thing all over again. So you'll find leafcutter bees living in holes, usually in wood. In my house, I have a few just little drilled holes that I guess there was a bolt or something put into it, but it's just an open hole right now, and I get leafcutter bees living in the bricks. I've seen leafcutter bees in natural holes in wood, drilled holes in wood. I've seen leafcutter bees living in the ends of raspberry canes, which are like tubes. And so leaving just a few raspberry canes out, it gives a home for bees to live in. And these are non-stinging solitary insects that will not sting you. They're beneficial for your garden. They do good work pollinating. And all they ask in return is just a few little round pieces of leaves from plants that probably won't miss them anyway. By the way, the purple flower that you see there is an alfalfa flower. Leafcutter bees are used agriculturally for pollinating alfalfa. And this is sort of a little known thing, but the alfalfa flower is kind of a special flower. It's usually kind of curled up, and when you if you're a bee and you reach in there to try to get at the inside of the flower, there's a part of the flower that pops up and it'll hit the bee right in the face. Honeybees hate that, and bumblebees hate that, and they just won't tolerate a flower that springs open and slaps them. But for some reason, leafcutter bees don't mind. So they will pollinate alfalfa flowers. And so leafcutter bees are raised intentionally for pollinating alfalfa to make alfalfa seeds. Just a piece of agricultural trivia. We have, as I mentioned, 800 different kinds of native bees in Canada, and they're all beneficial to your garden. They are almost all solitary. They're almost all not aggressive, uninterested in stinging, and this is an important part of the natural ecosystem, and also a really important part of having a sustainable agriculture system. An important part of having a healthy garden is having these native bees. So learning more about them, I think is it's almost as important as learning about how to plant seeds and how to harvest vegetables. Learning about the bees that are making your plants grow. That's part of gardening. We learn about these flies, hoverflies, the bee flies. They're actually much more important in pollination than we have previously realized. It's difficult to study them because they're so timid. It's even difficult to photograph them because they're so timid, and they move so fast. And they also, well, they just look so much like bees. You have to look really carefully to even tell that they aren't. So they haven't been studied very much, and that's just beginning. But the studies that have been done show that they're probably much more important in our agriculture and in our ecosystems than we realized. Butterflies are a key indicator of so many things, of plant health, of pesticide prevalence in the ecosystem. People are using butterflies in studying climate change because of the way that the change of seasons affects their stages of life. Butterflies are a minor pollinator. We include them in our list of pollinating insects. But we like butterflies so much that we would always have them on the poster about pollinators anyway. And like I've said before, moths are very similar to pollinators. They are a minor pollinator too, but I don't think that we have fully estimated the amount that moths are contributing to our ecological pollination. We see moths on flowers all the time, and so they're undoubtedly pollinating wild plants, and they have specific affinities for certain kinds of plants. So there are definitely certain kinds of wild plants that depend on certain kinds of butterflies and vice versa. One of the main questions that I get when I talk about pollinators is concerns about stinging. And so just to reiterate how that works, we have 4 different kinds of insects on this page. There's a honeybee at the top left and a wasp just below it. There's a squash bee at the top right and a hoverfly at the bottom on the right. And the two over on the left, the honeybee and the wasp, they're the ones who may sting if you get close to their colony, to their home. They don't really have any interest in stinging unless they're actually directly physically threatened. If you tried to pick them up, then they would try to sting you, but so would any kind of animal. Leaving them alone, you can get really close. You can get right up close to them, and they are not interested in stinging whatsoever. It's only when you get close to their home, and that's when especially wasps will get really aggressive. So we are concerned about having wasp nests in places where there might be classrooms of children, for example. But out in the garden, really, stinging is not something that we should be concerned about. And then there are hundreds and hundreds of species of bees that are solitary bees that don't have a reason to sting, and half of them, the males, don't even have stingers. And then a lot of the insects that you might think are bees are actually flies, which can't sting. And their main thing is just to get away from you if they see you. How to take care of bees is just, I always think, just the same way as taking care of any other kind of animal. Any animal that you want to take care of needs food, it needs water, and it needs shelter. And the trick is understanding what that food is and what that shelter is. So the main rule of thumb is that pollinators feed on pollen, and pollen comes from flowers. And so you can imagine a garden that blooms just in the midsummer, maybe an orchard of apples that only blooms for a few weeks. That's a great source of pollen for that short time. But what about the rest of the time? What are the bees going to eat when the apples aren't blooming? What will the bees eat if you have flowers in your garden that are only there between June and September? They need food in the spring and they need food in the fall. So here we have a picture of two wild plants. The yellow one is called coltsfoot. It's one of the earliest blooming plants, wild plants. Sometimes it blooms even in early April. We can see coltsfoot. And the purple flower is New England aster, blooms late into the fall. We would encourage your first step if you're trying to plant pollinator-friendly plants in your garden. Don't worry about all those lists. Don't worry about which kinds might be better for this kind of butterfly or that one. First thing you should do is find plants that bloom really early in the spring and find plants that bloom really late in the fall. And those will be the ones that the pollinators are missing most, because that's when they will be the hungriest without flowers during those periods. That's where you start. Then fill in the blanks, fill in the gaps, find good pollen-bearing plants that are wide open, that have lots of pollen in them. And the main thing is to provide sources of pollinating plants for as long a period as possible. Most of our pollinators are not too specific. They'll eat pollen from any kind of plant. You'll read about some pollinators that only like plant or certain plants. They only will eat pollen from a particular native species, or and so if you want to attract those particular kinds of pollinators, then you plant those particular plants. But most pollinators will take whatever they can get, and they're happy with just having any blooming flowers. Providing shelter. The main thing in a garden means providing a place that's free from pesticides. That's probably the main habitat challenge that pollinators would have in an urban setting, would be exposure to pesticides and pollutants. Having a nice organic garden where they can live safely. They'll find their own places to live in the garden. Where are those places? Well, you might wonder, where do your bees live? If you see these leafcutter bees or you see these mason bees, where are they coming from? Where do they live? You only see them on the flowers, but you don't see them in their homes. And we already talked about how the squash bees live in a little hole underground. They live in nests that they dig under the squash plant. or under the pumpkin plant. And so you might think, okay, so the babies are in this nest over the winter and into the spring. And the nest is about 3 or 4 inches down. So my suggestion is if you have pumpkins or squash or zucchini, count on there being little baby squash bees living 3 or 4 inches down underneath where those plants were growing. So if you cultivate your garden, cultivate it only about 1 inch deep, maybe 2 inches deep, not 4 inches deep. And people who will say that deep double digging is the way to get good soil. Sure, true enough, but deep double digging will actually harm a lot of those ground nesting pollinators that are just trying to live underneath the plants that fed them. So cultivate shallowly and save the bees. 30% of our bees are like the leafcutter bees that live in little holes. Maybe it's a hole in the side of your house. Maybe it's a hole in a piece of wood. A lot of people drill holes intentionally in an old piece of wood, and they find bee families living there. A little bit of raspberry cane can go a long way. Just leaving some sort of tube that's a natural stem that bees can nest in. That works. Not picking those up. You can give places for bees to live if you have, say, a row of shrubs, and you might think, well, I'll put lots of mulch underneath the shrubs, but there aren't weeds growing under the shrubs anyway. And because the shrubs shade the ground doesn't dry out very much. Those are the two main reasons why we mulch. Why not leave that ground bare? It's not growing weeds. It doesn't dry out. Why mulch it? And that means more of these bees can find a place to dig a little hole and live in the ground underneath your shrubs, because they will, and then they'll come out and pollinate your flowers, and they won't get in your way because you're not using that space underneath the shrubs anyway. Just leave it bare. A little bit of bare ground in a strategic place that can give a home for native bees. We attract butterflies to our gardens, whether or not they're good pollinators, just because, hey, they're butterflies. I like butterflies, and I plant butterfly attracting flowers because I like to see them. I've had great success with zinnias, great big wide open flowers that are horizontal. They make a landing pad. Asters, you see the purple flowers here, they're more or less horizontal. It makes a landing pad that the butterflies can land on and sit on. They seem to like that a lot. And the butterfly bush, last year, I always had butterflies flying around my butterfly bush every single afternoon. It's not a native plant, but it is one that our native butterflies really like. It really works. Remember that butterflies only spend a very tiny fraction of their lives as adults. We see them during this very, very narrow part of their lives when they fly around. Most of their lives, they are caterpillars and chrysalis. They form into a chrysalis and they live underneath a leaf. Monarchs often make their chrysalis on a milkweed plant, so people plant milkweed plants to give a place for monarchs to do that. And every species of butterfly has its own preference of the kinds of plants that it uses, both for the larva to eat and for the chrysalis to form. Usually it's the same plant, because the larva will live on that plant, eating the leaves, and then form its chrysalis on the same plant. So that takes a little bit of research to find out which kind of plant goes with which kind of butterfly. But that, especially with butterflies, they're quite specific, and so it matters. Most butterflies don't migrate. We're very familiar with the idea of monarchs traveling from Canada to Mexico and then back and forth again. Well, most butterflies don't do that. They overwinter. So probably if you have butterflies in your backyard or had them in the summertime, it means you have them now. They're probably chrysalis. They might be eggs, depending on the species, but they're living in your backyard now. So having the right kinds of plants for them in the spring will be crucially important for those young butterflies when they wake up. So to review, we grow flowers that bloom early in the spring and late in the fall, because those are the times when there are fewer flowers around, and that means less pollen, and that's when our pollinating insects are more hungry. Simple and natural flowers tend to have more pollen. When we say plant native species of flowers, it just means that native species, um, they have smaller flowers, but they put more of their energy into making pollen because that's their job. They're trying to reproduce. So the flower's job is to try to make seeds, and by doing that, to do that, they need to make pollen. So native plants that haven't been developed and cultivated and made great big domesticated flowers, they tend to have more pollen in them. Bare ground is a good place for bees to live. Underneath a shrub, behind a fence, someplace where you're not going to walk, where it doesn't matter whether it's just bare ground. That's a good place for bees to live, and they'll find that spot and they'll make their homes. As long as they're not disturbed, then you'll have more bees. And if they're the 30% of bees that live in little holes, a little piece of rotting wood is a good place for them to dig a hole. Or you can drill holes in a piece of wood and give them a place to crawl in and live and lay their eggs for the next generation. Hollow canes like raspberry canes, or certain kinds of ornamental grass that have a natural tube. Instead of throwing that out as yard waste, just pile it up somewhere out of the way, and the bees will find those tubes and use them for homes. And finally, not spraying pesticides is the main thing that makes an urban garden pollinator friendly. When we have a safe place and lots of food and shelter, we get lots of beneficial pollinating insects, and there's no need to worry about the beautiful pretty green bee stinging. They don't do that. So it's a quite nice thing to do, and it's part of making your garden healthier. It's part of making your flowers more abundant, and it's part of making your food more abundant too. I'd like to pass along some information about another organization. This is called Bee City Canada. It's an organization that formed a few years ago, and its job is to sign up municipalities to adopt pollinator-friendly land practices. So there are now 86 cities in Canada that have registered as bee cities. It means that they've adopted municipal plans that take pollinators and pollinator health into account in the way that they manage city land. Bee City Canada also has a few thousand individual members, and I encourage you to go check them out. They have lots more information about how to make your garden more pollinator friendly and why that's a good idea. And through this network of people and bee cities, we're really getting the message out. Thank you very much for your time. This is a really important topic, and I'm glad that I could offer a little bit of information about it. There's so much more that I couldn't fit in this, but I hope it's a good starting point for you to learn more. Thank you all very much, and a good season in your garden.